Hi everyone, I'm Marty and welcome to another great edition of Astronomy for Beginners. And today I'm going to do a video guide on how to process LRGB images. Now basically, for your guys that are unsure what LRGB imaging is about, as you're aware, is if you've probably done astrophotography and you use a DSLR or a CCD, you run into like long exposures of deep sky objects like galaxies and nebula. You'll often find that when you image these images, when you capture these images and you stack them together, you get one final coloured image. Now, the main problem with coloured images is that the resolution on the camera or the CCD is not as sensitive. Reason why I'm saying this, it sounds a bit crazy when I say it's not as sensitive. Basically, a CCD or a DSLR has a Bayer matrix, which basically what it does is it have the individual bits of the red, the green and the blue light wave spectrum. And basically they pass through each of these little separate pixels of these various colours, which basically, as you're capturing the data on an image, say like you do a 5-minute exposure on M31 for example, a galaxy, basically you do 5 minutes and basically during that time it will start going through the red for a little bit, the blue and the green light spectrums in separately per second, whatever exposure you're timing at. So once you get there, you get a final coloured image. The trouble is with this Bayer matrix, it takes a certain amount of light. That's when you lose the sensitivity. And basically, to get a coloured image, you need to take longer exposures to get as much detail as you can. When you do stack them, your images will not be as great compared to the LRGB images. Now LRGB images is basically a process. Basically it's a CCD mainly, and what happens is that there's no Bayer matrix across this camera's main chip. So basically you have a mono or monochrome coloured image. Basically the image will be black and white. The LRGB consists of basically what I have here. This is a QHY9. This is a mono CCD. Retails around about £1,700 just for the camera. That's not included the filter wheel and the full screw juicer and the filters with it. But inside here, as you can see here, you have this filter wheel system, and in this here there's a carousel of each of these filters. So when basically what you do is like they'll be coloured as a red, a green, a blue, and there's an luminance colour. Alright, so of these filters. Now they cost you can get them between like 200, maybe up to £400, and basically they are controlled by the computer, so you can move using the software of this camera and control each of these exposures. And basically what you do, you capture each of these filters. Say like I'm doing M31 Galaxy for example, I capture 5-minute exposures in red, so I do like 10 of them, and then I go on to green and vice versa, and you just keep going around till you get the complete obviously the complete light frames you get. Now when you first capture these images, they will appear black and white. Alright, the LRGB, basically what it does is it allows only one light wave pattern to pass through. So basically if you're taking the red, it will just pass through the red spectrum. And do the same for the green, goes up for the green spectrum. And basically what that allows this camera to do is boost the sensitivity up, the sensitivity rate of this camera. So basically what this camera will do is not only it collects a lot more data, it will collect more details on the nebula and the details in the galaxy. They'll be a lot more refined, and with that as well, being more refined, is that it will enable you to collect the data far much quicker compared to a coloured or DSLR camera. Due to its bay matrix, it has to have certain amount to pass through. So basically, if I was, say for an example, I was collecting say like the red spectrum of this mono camera, to get a really good image, say like I'm using the colour camera, and the colour camera I'm getting 5 minutes exposure to get a really decent image. With this camera, if I'm capturing that amount of detail, same sort of level of detail, I'll be using half the time of the exposure rate compared to the coloured one. So basically it halves the time, alright, speeds up the capturing the data time on this, using this method. And that's why a lot of the astronomers prefer to use LRGB imaging, because you get a much better defined image, and when you come to stack it together, alright, it will then result a final coloured image. But it sounds a bit crazy at first, so I don't want to throw you guys off, but basically that's the general idea of LRGB. There is another method called broadband filters, so I use broadband filters instead of the LRGB, but they're much more specialised. But again, it is the same process as LRGB. Now LRGB is a very, very complex way of imaging processing, and I'm telling you now, you will spend a lot more time on the computer processing and stacking the images more through this system than what you would do on a fully coloured or DSLR image. So you will need to spend a lot more time doing all these LRGB images. So basically what you got to do is, if you are considering taking it, be prepared that it's not just the extra money for the filter wheel and the filters and the mono camera and all the other stuff you're going to need, is you're still going to need to spend a lot more time processing the images. Obviously with today's guide, what I will do is I will go over to my computer and I'm going to show you a really good method which you can do, or basic free software that I use. Alright, and basically what I do, I will now show you how to process a LRGB image. It does sound very taxing, but believe me, using stacking all the images and using Photoshop CS2, which is apparently it's so easy to do. Alright, it seems very daunting, but believe me, it's not. Alright, so basically I will show you now how to do an LRGB image.
I'm on my computer. As you can see, I've got on my desktop, you see a great image of the Andromeda Galaxy and its companions. Many thanks to Andy Milner, who had processed this image of my capture, and I was quite astounded on his techniques that he used to get this image to an extraordinary amount of detail. Many thanks to you, mate. Well appreciated on your for helping me out on the processing on this image. Before we start, I'm going to show you a nice little handy tip. Now, LRGB imaging is not always an easy way of imaging. But one thing I have found out, and it works for me, this is my little process that I use. When you go out and you capture your luminance and your res and your green and your blue filters, images, you probably get confused when you start using your capturing programs to find out which filter is which. Basically, this is my cue card that I made, and it basically tells me when I use the Easy Cap software for the QHY CCDs, I basically use I number my filters based on the program. So if filter number 1 is here, it'll be a red. If filter number 2 would be a blue. Filter number 3 green, 4 purple luminescence, and 5 light blue. And obviously here I have my RGB setting here, and it also works for the narrowband as well, because I've got narrowband filters in a separate filter wheel. But this little cue card helps for me, because then when I number my filters based on the EasyCap software, because on that program alone, it doesn't tell you which filter it is. It's basically the number of that filter. So to identify which filter of each of the colour band, I will know exactly which filter is which. So when I'm capturing anything, I make sure that I do not miss anything at all in when I'm capturing, because it's so easily mistaken and you can lose track of it. So I usually take this card with me. It's laminated, and with this card I refer to it. If I get confused, I will find out which filter is which. So when I do swap even when I swap my other filter wheel for the narrowband filters, I'll know exactly which filter is which. A nice little handy little tip, and it will save you a massive amount of headaches and time. So what we do is now we skip out of that as we do it. Discard that. I'll sit out of the way. Right, as you can see on the desktop, I have a series of captured. These are basically my images, and you can see, as I mentioned before, it is processing, post-processing madness. In other words, when you start doing LRGB imaging, you will need to take a lot more capture frames to get a really good image. As you can see here, I have the luminance frames, which I click on there, and it gives me the series of luminance frames, alright, of 300 seconds. That's all my luminance frames. Then I've got the red series of frames. Again, I've got series of red. And then I've got green, series of green. And then I've got series of blue. As you notice, you see the numbers. Now this is what I want about the numbers. Right? You see the C4? That tells me that is a filter number 4. Alright, makes it a bit explanatory. Red, C1. Again, this will identify which filters you've used. Alright, hence the reason why that cue card plays ends, because you know which filter you've used, C3. So it all matches the amount of the frames, capture frames, that I need, so that I can stack them. Now, as you can see, LRGB, and then I include my darks. Alright, so I've got my dark frames as well. As you can see here, what I do is now, I'm not going to go fully in depth onto the Deep Sky Stacker. Alright, obviously refer to the other guide on the beginner's guide to stacking images using Deep Sky Stacker. That's in another video guide, so I'm not going to show you how to stack each of these, how to capture the images and then stack them. Alright, I'm not going to go into that in full detail again. Just refer to the other guide for that. Now, I've noticed video guides out there that do not demonstrate how to combine the luminance with the red and the green and the blue. Obviously, you see it as combining your red and your green, blue, grayscale images together to form a coloured image. But unfortunately, there's a lot of the video guides that fail to illustrate to you how to stack the luminance and red together. So what you do is, when you use Deep Sky Stacker, when you put the red together, add the luminance frames, which is C4 or whatever filter number you've combined, add the luminance and the red together, right? Has one grayscale, and then when you stack them together, you will then start to form one single stacked image. So basically what you'll have is, once you've stacked your luminance red, then your luminance green and your luminance blue, with the darks combined, alright, and you should get 3 separate fully stacked images of the blue, green and red combined with the luminance frames. Alright, so basically the luminance frames and the red frames together, luminance and green, and you see that. That basically now gives you the added luminance with those frames together. Alright, so that's now your RGB together. So what we're going to do is we're going to now open up Photoshop. Now I'm using Adobe Photoshop 2, which is a free software package, and believe me, it works perfectly. Astro post-processing works an absolute treat. So what we're going to do now, I'll go into File. What I'm going to do now, I'm going to now open up all my luminance red, luminance green and luminance blue images. So open the red. So that gives me the red. I'm going to open the green, and it opens the green. And then I'm going to open the blue. Opens the blue. Now, as you can see here, they're all grey images, right? This is what you'll get with mono images, alright? The camera will only detect a certain amount of light frames. But the thing is, you can see already different filters give out different level of detail. Alright, so you got the red, it's got quite a lot of detail, right, compared to a blue, there's, you know, a bit more of some of the detail in there, and then you got green and so forth, right, and it brings out certain different levels, alright, together. Now, what I tend to do is just keep them like so, in a line like that. Now, what we're going to do now, we're going to combine them together to give you one single coloured image. The different levels of detail that you can see, and this is the reason why our LRGB imaging is better than a standard coloured CCD or DSLR image. And this is what we're going to do. First, to start off simple, you click on the red picture. What you're going to do is you're going to press on the computer Control and A. What that does is it will select the image. You see it dotted all the way around like so. You're then going to press Control again on the computer, and you're going to Control C. Basically what you're doing is you are copying the image. Then what you do, you go into the File tab, like so, click on there, and you are going to select New. Right? Then what you're going to do is click on the name, call it whatever, M33, which is the galaxy, coloured. Like so, you can call it whatever. Go into your resolution to about 300 dpi. You can put more to give you a much better detail, but 300 seems to be a good sort of number. You then select colour mode, and then select RGB colour, like so. Click on OK, and then what it does is it will give you another tab, like so. Right, what we're going to do now, this is basically this is going to be the final image. But before we do that, we go into channels, we go across here where the pointer is, you click on channels. Alright, what you're going to do is over the RGB. Basically you've got the red channel, green and the blue channels. And what you're going to do is, where RGB is this frame here. You click on there, on the tab, and then you are going to, once you've done all once you get that coloured image, you basically go over to your channels. So you click on the coloured image frame, and then you select the red, press Control and then V to paste. What will that do is now that will paste the red channel into the final coloured image. We then go over to the green. Again, here's the green. You press Control A to select it, Control C to copy it. You go over to the final image and then you select the green channel and you press Control V. Well, that will now put on the green channel. Then what we're going to do now, do the same process again. Go to the blue channel, press Control A, Control C to copy it, go into the final image, go over to the blue channel, highlight the blue, and then Control V. Now what will happen is you should have a coloured image. Now what we do is we go into the RGB, and now that is the final coloured image. As you can see now, we maximise it. Okay, and that's your coloured image of M33. Now, a lot of the video guys fail to describe. Now, it just depends on what video capture program you use and all that. Now, not all stacking software can realign all the RGB images together. As you see here, now if we zoom in into the final image, if we go into view and we zoom in and we zoom in again, keep zooming, you'll notice that the image seems to be slightly misaligned. Now this has confused me a lot sometimes, but I've figured out how to do this. Now if your tracker wasn't great or your image is slightly offset, you notice that the blue channel, all the stars are not quite aligned together, and so same as the green and the red, it all seems to be slightly out. So basically all the red, the blue and the green channels are not properly aligned together. So this was what's giving this weird effect. If you zoom in, keep zooming into the image, keep zooming, alright, you'll start to get a much more zoomed in image, and you can see where all these channels are misaligned. Click on this icon here, and then what I do is making sure that all my tick boxes, because you can switch off all these layers, but if I switch all the layer, and what I do is I click on the blue channel, you can move each one as much, but if I click on the blue channel, select this tool, the move tool, and then basically what I do is I left click, and then what I do is hold the mouse button until you move the channels together, like so. You see what I've done there? I released it to move the blue channel in place. Going to the green. Now the green looks aligned, so I don't really need to move it. But again, same process. You select the green channel, select the move tool, and then you do it again. Press left button, hold it, and then move it. Alright? And then you do the same for the red. And then what you do is, once that is done, that all those coloured channels should be properly aligned. Now, I don't know what has happened there, but it seems to be, it could either mean when I'm doing my capture programs, I was doing it on different nights, but now what I've done now is I've moved all the red, the blue and the green channels together. So what we do is now we basically just zoom out, and now that's now produced a final image together. So the red, the green and the blue luminance frames, which have been stacked together and then realigned on the final image to produce a coloured image, as you see here. LRGB imaging post-processing is not quite as easy, but this system seems to work for me. There are many other methods and techniques you can use, but I hope this gives you a good general idea what LRGB involves. I would not recommend to advise beginners to start this type of capture imaging and processing, as it's not always straightforward. For beginners, I recommend you using a DSLR or a coloured CCD, but if you're going to use a mono and you want a coloured stacked images using these separate filters, you will spending more time post-processing, stacking the images and all that, and it takes a lot longer than just stacking a coloured image together to produce a final result. However, when you use LRGB images, you can see already that using this process reveals a lot more refined, less pixely image. Now this needs to be post-processed furthermore to adjust levels, but I'm not going to go there just yet. But as you can see, this is just how to combine your grayscale together to form a coloured image. And you can see it's not always straightforward, but with a little bit of practice you will get there. I hope this video guide has helped you guys and girls. Please feel free to comment on our forum, and look forward to the next video guide. So thanks again, thanks for watching, and clear skies.